ask directly or find Wikipedia or anything, sir. To NE square over M star epsilon naught. So again, in CGS unit 4 pi NE 4 pi NE square over N. 4 pi NE square over N. You see, now I want you to have pay attention. You listen to me.
Okay, doctor.
So you can see my screen. Typo error again. I want to mark in red so that you can see. The lack of an equal sign. So omega p is equals to this part. So here you need to insert omega p equals to this 4 pi n e square over m square root. So that's why I feel confused. So you can see this is your plasma frequency. What I highlight in blue here. So radian per second in CGS units. So the SI unit is here. So this is related to the electrons charge, epsilon naught, the mass of electrons. Okay. And Ne is the number density of electron of the material. Epsilon naught is permittivity of free space. So the calculation is depends on you want to use the SI or you want to use the CGS. All right. So this paper keep on having typo errors. Luckily, I feel confused and then look at it. So sometimes if you confuse or don't really know how it is, and then you just type the name of the atoms and then you find it. So from here you can find your omega p. It depends on the formula. The formula are okay, but it depends on whether you want to use SI or you want to use CGS. But I will advise you to use SI. Okay. So if you use SI, then you use this. You use this. Then you no need to follow this. This is CGS. And the formulas are okay. The formulas apply both to SI or CGS. So this number, sorry, I should not take the grade. Just do this. So this one, the damping constant, you give the values. This is the omega, is the variable. You can change. You can change from 0 to some values. And omega p, not square, omega p, you determine from here. Okay, you use whichever suitable. You use SI, then different. And then, okay, wait for a moment. I stop sharing first because I've forgotten to record. Okay, so now got and then share. Okay, so this, is it okay? You still hear me, yeah?
Yes, doctor, I can hear you.
Okay, so this gamma is the damping constant. You give the value, okay, a good, well-prepared material, then gamma is small. Not so good material, then the gamma is big. This is damping, I mean the loss. And omega here is the variable frequency. You change it. For example, for sine theta, if you want to plot the sine theta versus theta, then you change the theta, right? I think you know about this. If you want to get changes with omega, then you do like this. Okay, and then this is the plasma frequency based on this formula. You can change it if you want to use the SI. And then the K here is from here. Okay, this K is depends on omega naught and omega, and also the damping here. So it's a bit messy, but many terms. But all the terms you can find the values. And then when you know all this, then you have no problems to find your gamma. This is gamma in terms of okay, in all here, and alpha is come from here. Okay, and then your delta is come from above somewhere. There are many terms here. So you take the exponent, then you can find it. Okay. So you have the gamma z square on gamma z square. This is like nonlinear equations. When you want to find this gamma z, lambda z or gamma z, they are the same. So, but the phi, you can determine, this is a constant. You can, sometimes you can ignore the constant. You can let phi not equal to 0. This is directly from here. Omega is something that you changing. Variable C is a speed of light. K is come from here. Z, okay, Z here, you make it values. Z is the distance traveled in the material. In the distance traveled in material. This is damping. This delta you can determine from above. Okay, delta from here. And beta. Can you see any beta? Yes, beta is from above. Okay. Beta is the nonlinear coupling. So beta is the value that you give to the system also. Okay, even though beta is defined as this, but beta is something that you define. Okay, so the kappa here is the spring constant for the expansion of second order of the potential. Beta here is the constant also, so you need to define this.